Hey there, I'm Taylor. What if I told you that in the next 20 minutes, you were going to build an AI agent that can actually shop on Amazon for you? Not just answer questions about products, but an agent that can literally open a browser, search for what you want, analyze the results, and add things to your cart. Not only will you build it, but you'll learn about key agentic concepts along the way, such as state, graphs, nodes, and edges. We're going to use LangGraph for the AI orchestration, OpenAI for the intelligence, and Playwright for browser automation. And I'm going to build the entire thing from scratch with you right now.
I want to start here with a high-level architecture diagram that just goes through the entire workflow of the agent. And I'll start with the capability domains that we see in the tool executor. We have three for this particular example, the first one being session management, product search, and then add to cart. And then under each of those capability domains, we have tools that the agent can execute, such as check login status for session management, start login process, and log out. For product search, we have obviously, searching for Amazon products, getting product details, and extracting search terms. For extract search terms, we're just taking the user's input. If it happens to align with the product search capability, we're then extracting a search term out of it using an LLM, and then using that as the search term that we apply to the browser automation whenever we're actually searching for a product. And then, of course, add to cart. Two interesting things about session management and why this is a capability we're focused on for this agent is that we actually need a session, a valid user session, to add things to cart. For product search, you could just go to Amazon.com and search across various products without actually logging in. But to actually add something to a cart, we need a session. The second thing is a super interesting one. We're actually using persistent context with Playwright. And why that's important is because we can't pretend like we're able to sustain one browser across the entirety of the interaction with the user. And because of that, we need to persist the context of the session itself for Amazon across the different instances of the browsers that are created. So an example of that could be that we're checking our login status, and then we close the browser, and then we go into product search and we spin up a new browser to go and search for the product that the user is asking you about. We need to be able to sustain the context of the session so that we're able to search for that product and then ultimately add that to cart. The other interesting thing too is that not all of these actions and tools require a browser to be spun up and visually seen. So an example of this would be like search Amazon products obviously requires some level of browser automation to be spun up so that we can see what's actually being searched for. But get product details can actually be headless. And we don't need to have a browser experience for the automation to go and get information about the product to show to the user. So that's why session management is here as a capability domain, because it's serving those two purposes. Now, up in the external services, Playwright is actually serving as our browser automation tool. And we'll see in just a second when we go to the code what type of utility we built that we're leveraging across our tool set. And then, of course, we have our shopping agent. And our shopping agent is going to perform this action loop across these capabilities with these tools, performing these tool calls and getting a response, and then using OpenAI as the LLM for the reasoning and intelligence. And then we have the user who's actually submitting the messages and expecting back a response. So this is just a high-level architecture of what's going on behind the scenes as we start to build our agent out. Okay, great. So let's jump into the code. So the first thing I want to show you is the Playwright utility. Now, this is meant to act as a centralized utility for all of our browser automation. Now remember, we have different tool usages, right, for capabilities. So we have login, we have add to cart, search for products, and each of these are going to leverage our utility in a very different way. And we want to make sure that we're able to support that in more of a robust fashion so that if we create more tools to add to different capabilities or even add new capabilities with new tools, we can leverage this centralized utility to support that through the browser automation. So one thing I'll show you is go into login tools. So for login tools, we have this at tool annotation here for LangGraph that allows us to create this tool, for instance, check login status, and we're going to leverage the validate session simple function through the Amazon automation that we import through the utility. And so here's all of our tools that we're going to leverage for the login process. And It's the same structure as we think about product search tools and also add to cart tools as well. One thing I want to point out here, going back to login tools, is also this array. So I want you to take note of this array because it's super important in how we actually give the agent the context around the tools it has the ability to use. And this is sort of the starting structure of that. And we'll actually check that out more when we go to our agent. So here's our agent. So I've created more of a blueprint of the type of to-dos we have to do to actually build our agent. One thing I want to start with is just kind of explaining the state. So when we think about state, this defines what our agent remembers across the conversation. So it's a shared data structure that represents the current snapshot of your application. So it can be any Python type. It's typically a type dictionary or Pydantic base model. And within this, we have our messages variable. Now, we have an annotated list of any message. Any message is actually a polymorphic type that LangGraph supports that is able to have things like an AI message, human message, chat message, system message, function message, tons of messages, which helps really make sure that everything is centralized in terms of our state. And then add messages is a function that merges the two lists of messages and updates the existing messages by the ID. So it really takes a lot of the legwork out of what we have to build to actually make sure that all of our messages of all of these types are actually being added back to our state. So the next thing we'll do is actually implement the model. So we'll have the chat OpenAI function here. And for the model, we'll choose GPT-4o mini, nothing crazy. And for temperature, we'll set this at 0.1 just to keep our responses consistent and focused. We'll go to our system prompt next. So we'll say you are an intelligent, and it was perfect. We can go ahead and just start tabbing some of these over. For session management, we can say, always check if the user is logged in before shopping actions and also guide through the authentication if needed. Perfect. And then for intent recognition, we can start to talk about sort of the nature of the type of requests that the agent will receive. So we can do things like search. I'll go ahead and just tab this over so we can review all of this. So we can be a little deterministic here in terms of how we're identifying the particular capabilities we want to leverage based on the intent that's recognized. So for this one, for example, this is search. The user will indicate that they are looking for a product or products and go ahead and use the search Amazon products tool for that. So we can do the same for product analysis and then finalize, which is adding to cart and checking out. I haven't incorporated checking out because I'm not brave enough to do that, but that is always an option of creating another action that we want to support, like checking out after we add things to cart. I think we're okay just sticking to this. I want to keep this super simple just for the sake of the exercise. Whenever you get the code, you can always expand this yourself and play around with it. Let me know how that goes. So the next thing I want to do is actually implement the tools. Now, I mentioned that array of tools that we had inside the login tools. So we'll go ahead and call this Amazon tools. What we'll see here is that we're actually importing the login tools, product search tools, and cart tools as part of the tools we want to make sure we're leveraging and giving context to the agent on. So for this next to do, we're actually going to bind these tools to the model that we created above. So we'll say llm.bindTools, and we'll pass in our Amazon tools. And what this does is basically just gives the agent the context of the tools it has to execute based on the condition of the user input at the time, the overall state, and how it's reasoning against all of that. So now that we've done this sort of initial setup, it's time to create our agent. So the first thing I'm going to do is actually incorporate the system message for this agent. And really what this agent is doing as a whole is serving as the agent function for everything we're going to be leveraging across our graph nodes and edges, which we'll get to in just a second. So the first thing we'll do is define our system message, which is our role as system. The content is the system prompt we have above. And then we'll have our messages here. And this is really just to merge the system message with everything you and the agent have said so far. So it's just concatenating the system message with the context of this messages attribute from our state. The next thing we'll do is actually call the LLM with tools.invoke for our messages. And this is just sending conversation history to the LLM and integrating the tool usage. So it's kind of bringing it all together. And then the last thing we'll do is actually return the response with the updated state that contains the most recent message from the LLM. So after we do that, we can go ahead and start creating our graph. So I'll go down here, and the first thing I'll do is we're going to say builder is equal to state graph, and we'll pass in our state class. The next thing we'll do is implement our nodes. So nodes are basically Python functions that encode the logic of your agents. They receive the current state as input, perform some sort of computation or side effect, and then return the updated state. So the first node that I want to create here is going to be the builder dot, we'll go ahead and tab complete this just for the sake of time, and I'll explain it. The first one we're going to do is actually builder.add node for our agent in using our actual agent function from up here. You can think of this as sort of like our thinking node. The next one we'll do is we'll add node for our tools, and we'll use this instance of tool node here. This is specific to LangGraph to be able to pass in the Amazon tools that we want to have at the disposal of the agent as tool nodes for the agent. So now we can move on to the edges. So where nodes were functions that encode the logic of our agents, edges are functions that determine which node to execute next. And they can be conditional branches, they can be fixed transitions. So the first thing we'll do is add an edge for our agent, and we always have to have a start here established. The second thing we'll do is add conditional edges for the agent and throw in the tools condition. Now, tools condition is a pre-built conditional routing function used in agent workflow. So its primary purpose is to examine the current state of the graph, check if the last message contains tool calls, and determine which node of the workflow to call next. And then lastly, we'll have our edge for tools and agents. So now that we have our nodes and edges, now we want to incorporate our memory. Let's get rid of this to do and go down here, and we can tab over and say memory is equal to memory saver. This is just adding memory so the agent remembers the conversations. And then we can return our graph, our builder.compile, and check this check pointer. There are use cases where you'd want to have your agent remember nothing and be relatively stateless, but we want this to be stateful, and we want to make sure we're remembering across all of these different transactions and interactions for the agent. So now that we have our agent, we've done a lot of the legwork in terms of configuring the structure that our agent needs to actually function and go do its job. Now we just need to worry about the UX. So down here for run agent, this is really our CLI interface that makes it feel like a real product. The first thing we'll do is just do some print statements. We'll create an instance of our agent, and then we'll actually create our config. And the config is just a persistent conversation thread that enables memory across messages. So here for the configurable, we have to pass in a thread ID, and we can name this whatever we want. For this sake, we're doing demo session. So what we'll do next is we'll go into this while loop. We will collect the user input. We'll check to see if it's any of these, quit and exit that make us want to break out of the while loop. We'll check to make sure we have user input, and then we'll go ahead and start creating the UX for our assistant. Now, the one thing we're going to want to do here is actually stream the agent's responses in real time. And what this means is that we're actually going to stream the reasoning the agent is actually doing behind the scenes and show that to the user as it's thinking and as we're actually executing the agentic flow. So we'll iterate over the agent stream here and get this chunk. We'll extract out some print statements here from the chunk to be able to show to our users as this is actually happening. So if we go up here to show reasoning, we can go ahead and tab over, and I can kind of walk through this. What we're going to do is actually iterate through the chunk.items and get the node name and node output for each item. We'll check to see if it's node name of agent or tools. In this case, if it's agent, we can go deeper. If it's tools, we'll just let them know that we're running tools. And then we'll actually get the message out of the node output. Once we do that, we can see if the messages has an attribute of tool calls. And if it does, we can get the actual tool name that's being executed as the agent goes through its sequence. And this is a little bit strictly typed, but it's just to give an example of saying, if search is in tool name, then print searching Amazon. If login is here, then checking login, just to give the user some idea of what's happening. So now that we have our show reasoning, the last thing we want to do is just show our final response. So we can show the reasoning here, and then if the agent's in chunk and messages in this agent attribute, then we can extract the message and actually print the message content. So overall, that's really everything we need to do to get this running. We've created our graphs and our agent structures. We've done the preliminary setup. I think we have a decent enough prompt. And now we have some user experience pieces incorporated here that I think are going to be really nice for us to go through. All right, so I think we're ready to go ahead and test out our agent. So what I'll do here is activate my virtual environment and run the Amazon agent. So this is going to show me Amazon shopping agent. Tell me what you're looking for. Type quit to exit. Perfect. And I'm looking for a new computer mouse. Awesome. And then it'll go through and extract the search term out of my prompt. And it looks like it's computer mouse. It's going to scrape the top choices here. And then it's going to give me the sort of 5 different options that it found. So Logitech Signature 650, the Acer wireless mouse. Let's do like random ones. So let's do the so let's just keep it super general and say, can you compare the Acer with the HP mouse and tell me what people are saying about each? Cool. So what's cool about this is that we talked about in the very beginning, from a browser automation perspective, there are certain use cases that require us to actually spin up a browser that the user can see. But there are other use cases where we can actually just have this act as a headless flow through the browser automation tool for Playwright. But so here's the comparison: Acer wireless mouse, the HP X3000. So we can get a nice glimpse here too, just around like the persistence of state within the agent, because I was able to ask a pretty general question around like the Acer and the HP in terms of the comparison, and it knew exactly what we were talking about. So that's an example of just like being able to lean on that state and make good reasoning decisions based on that state. So Acer wireless mouse here, HP, the X3000. So I'm going to go ahead and say, it looks like we got some customer reviews here. This mouse is very comfortable to use, especially for long periods. Awesome, that sounds great. So I'm going to go ahead and get this. So I'll say, can you add the HP one to my cart? Let's see how that does. So this will actually spin up a browser instance where we will get the HP product URL and then navigate to that product URL. And that's also leveraging state. And this will then go directly there. So perfect, here's my HP mouse, and add it to cart. And then this browser should shut down. And then I should get like a nice message showing me that the HP wireless mouse has been added to my cart. Excellent. So that's great. So this agent's working super well. Again, it's pretty simple, but we can see the power of just the different capabilities that have various tools that we can leverage for our agent flow. I hope you liked this demo today. I'll be committing this code to a repository so that you can fork it down and play with it, maybe add new tools, add new capabilities, just kind of see where you can take this. And definitely let me know what you built in your feedback as well. Please like and subscribe for my YouTube channel, and I will also post a link to my Substack in the comments. Cool. Thank you.